Welcome to another edition of Coonrod's Corner, brought to you by the Rogers Corporation. Today's topic, COOLSPAN TECA, thermally and electrically conductive adhesive. Here's your host, John Coonrod.
Hello, welcome to Coonrod's Corner. My name is John Coonrod. I am a Senior Market Development Engineer for Rogers Corporation, Advanced Circuit Materials Division. Today's topic is going to be COOLSPAN TECA, and that is a thermally and electrically conductive adhesive film. Now, thermal management, as we all know, is becoming more challenging as technology develops, and the COOLSPAN TECA is here to address some of the issues associated with thermal management. An earlier Coonrod's Corner did address some of the basics of thermal management, and that can be used as reference for some of the topics that I'm going to talk about on the next few minutes. The high power applications very often in the microwave industry are using a microstrip configuration that is bonded to a heat sink. And a good representation of this is shown here. So on top is the microstrip transmission line in this case, where RF heating could be generated on the signal conductor, and the heat path goes through the circuit and into the heat sink. Now, ideally, the connection between the circuit and the heat sink is very critical to ensure that you have good heat flow between the circuit and the heat sink. Now, there are several different ways that you can have the thermal connection between the circuit and the heat sink. Some of the more common methods are fusion bonding, sweat soldering, a mechanical press fit maybe. And in this case, we're going to be discussing a conductive adhesive that is thermally and electrically conductive, and that's our COOLSPAN TECA. So this method is actually done by a lamination cycle that is very friendly to circuit fabrication, and some of the properties are shown here. The COOLSPAN TECA is available in 2 mil thick and 4 mil thick. The thermal conductivity is very outstanding at 6 watts per meter per K, and the electrical conductivity is also good, shown here as resistivity, the inverse of course, and that is 0.00038 ohm per centimeter. And then the TG above and below the CT is also considered very good at 45 and 70 parts per million per degree C respectively. Now, the other benefit with the COOLSPAN TECA is that the flow is very predictable. And where the benefit there is, if the COOLSPAN TECA is used in the case of cavities, where you want to have the COOLSPAN do the bonding in areas that needs to be bonding, but also you could have openings where you do not want bonding, and having predictable flow can be very critical for that. So the COOLSPAN TECA is formulated to be very good for very predictable flow. High temperature performance and reliability is a given. The material is formulated to do exactly that. It's very robust in multiple laminations. It's robust for multiple lead-free soldering cycles, so thermally very robust, and it's also very friendly to different lamination cycles. We have done studies showing the COOLSPAN TECA bonds very well to aluminum, chromate treated aluminum, as well as ENIG, electrous nickel immersion gold. That technical report is available upon request, and the following slide shows a quick overview of some of the data that we have from this report. So initially, what we're doing here is lap shear testing, and that is essentially 2 pieces of metal that are bonded together with the COOLSPAN TECA, and then a shear test is done to see how much strength it takes to pull these apart. Now, we're getting initially, as you can see, in the unconditioned state, a lap shear force of about, or a lap shear stress of about 2,000 psi, and that's considered extremely good. And then you can see the variety of different testing we've done here with 288 degrees C testing for 1x, or 1 cycle of that at 10 seconds. And then we repeated again 288 degrees C testing for 10 seconds for 3 times through, and then 5 times through. And you can see a slight difference in the stress numbers on the lap shear. But again, these are in the range that is considered very good. Now, a more aggressive testing sometimes is the 85-85. That's 85 degrees C at 85% RH. And that was at a 200-hour limit, and also we took that even as far out as 1,000 hours. That's a pretty aggressive test, and you can see the numbers here compared to the baseline did not vary much. So again, this shows that the material is very robust to different environments. And then finally, we did some testing at elevated temperatures that are dry, 150 C for 10 days, 170 C for 10 days, and also 190 C for 10 days. And these are all considered very aggressive. Again, you can see the performance that the COOLSPAN TECA performed very well, showing that it is a thermally robust material. That concludes this edition of Coonrod's Corner. Thank you for watching.
For additional information and technical tools, if you are not already a member, join the Rogers Technology Support Hub and gain access to calculators, technical papers, and more of Coonrod's Corner and other informational videos. Rogers Technical Information is also available at your fingertips with the Rog mobile app, available for the iPhone, iPad, and Android devices. Check it out today.